definitions that you need to know. So the first one is this symbol. It looks like an upside down A, or a V with a line through it. So this is a symbol for all. So all I mean by that is if you come across that symbol in a sentence, you read it as for all. So an example of this is x is greater than 0 for all x in the naturals. Right? Because every single element in the natural numbers is bigger than 0. So that's how you would read it. X is greater than 0 for all x in the naturals. Okay? So second is another symbol like this. It's a backwards E. So this is a symbol for, so all I mean by that is I'm repeating what I said before. So backwards E is a symbol for there exists, okay? So an example of this, remember last week we talked about division. So if A divides B, there exists an element L in the integers such that A times L equals B. Okay, so it's implied that what I mean by this is there exists at least one. So there could be multiple. So for this example, there's one. But in general, when I do the backwards E, I'm saying there exists at least one. Okay, there might be multiple ones. We don't know. But there's at least one. There may be more. Okay, so another symbol is this one. So it's like a colon next to an equal sign. So this means we're setting something equal to by definition. So setting something equal to by definition. Okay, so like if I wanted to say A is equal to the set X in the reals such that, I don't know, X is less than 1 or something. So I just want to define A as that thing. All right, so lastly, an integer is prime if the only positive divisors are 1 in itself. Sorry, if its only positive divisors are 1 in itself. Okay, so for example, 4 is not prime because 2 divides it. Okay, but 3 is prime because the only positive divisors are 1 and 3. Okay, excellent. So now we're going to move on to the next section. All right, so now we're on section 8 with polynomials. So I just want to start with a couple of definitions. So first, a polynomial, and so I'm going to shorten that to poly a lot, is a function of the following form. So maybe let's call it f of x, and so this is equal to, let's say, a sub n. So that's just one number, but it's numerated as n, x to the n, plus dot dot dot. That just means I'm going to continue the pattern. You haven't seen the pattern yet, but I'm going to continue it. a1x plus a0. Okay? So this is the same as we have a summation where our index starts at 0 and it goes all the way to n of a sub I x to the I. Okay? So that's why I was calling these the way that I was. Excellent. So that's what a polynomial is. So the AI are called coefficients of f of x. Oops, I forgot. So going back to the top, so x is a variable. Well, it's the variable here. And then n is just some natural number or 0. Okay, so notice that's all the counting numbers or 0, right? The union. And the AI are all in the real numbers for all I equals 0, 1, all the way to n. All right, so now those AIs are called the coefficients of f of x. If we continue on down, we talk about the third definition. We say two polys are equal if all their coefficients are also shorten coefficients to coef are equal. So that also implies that like the ends have to be the same, right? So let me show you what I'm talking about. So IE just means meaning for, so I'll make up two polynomials. So P of x equals a sub n x to the n plus plus a0 q of x. Let's say that that's b sub m x to the m plus b sub 0. For those to be equal, meaning p of x equals q of x, or p equals q, sometimes we write that, m must equal n, and b sub I equals a sub I for all I 0 to n. And so now you could pick n or m because they're equal. Okay, fabulous. Another definition. If f of x a polynomial, then the degree of f is the largest index such that the coefficient is non-zero. So index, all I mean by that are these i's that we're talking about. So the degree of f is at most going to be n, right? So a of n might be 0, we don't know, okay? But it's certainly not going to be n plus 1 because we don't even have it that high, okay? So those are definitely 0. So let's talk about some examples and we'll try to work them out together. So for f of x, we have x squared plus 2. So the biggest coefficient that's non-zero is going to be a2. Okay, so here's how we write it. We write deg, and then the name of the polynomial equals 2. Okay, now for the next one, we have, and so another thing that you can get tripped up on is they need to be in order. So here's my biggest one. So degree of g equals 3. Okay, so it has nothing to do with the actual value of the coefficient, just as long as it's not 0. Okay, so it could even be negative. H, so degree of h, well, that's going to be 6. All right, and so this is actually a special kind of polynomial. This is called a monomial because it only has one term. All right, so for p, so 100. So what coefficient is that? Oh, that's a sub 0. So the degree of p is going to be 0. Okay, so think p of x equals x to the 0 times 100. Okay, this also has a special name. This is called a constant polynomial. So what about if I said q of x equals 0? Well, that's weird. So note that the coefficient is 0 for every single term of x. So the degree is not well defined, right? So I can't say, well, x to the 0 defines my degree because that coefficient is 0. So we just say that degree is not well defined, but sometimes people will say the degree is negative infinity. So for this class, we'll just say that it's not well defined. Okay, moving on to our next definition. So this is something important. So for n in the integer, n in the naturals or 0, so n could also be 0, this blackboard bold p sub n is going to be equal to, so remember how we read this, so these are all the things, all the elements that we could choose from. So we can choose any polynomial such that the degree of that polynomial is less than or equal to n, or it's the 0 polynomial. Okay, so we always want to include the 0 polynomial So if someone had defined the degree of the zero polynomial to be negative infinity, it would still fall in here, but we just say actually specify what it is, because in our class we're going to say it's not well defined. Okay? So this is a very important definition. So let's talk about an example with this. Consider, so I have three different polynomials here. So we have G, we have H, F, and Q. Oops, we have 4. So which of these are in P sub 3? Okay, so I'll give you, you can pause this video and you can check that out. So let's start with the first one. So the degree, so really what we need to look at is it either the zero polynomial or what's its degree? Is the degree less than or equal to 3? So the degree of G, oh, well, that's 3. Okay, so that's fine. So G is in our set. Okay, so the degree of H, oh, the degree of H is 4. Okay, so that's not going to be in our set. And then we could do similarly with this one and then this one. But this one, it doesn't have to do with our degree. It's just the zero polynomial is always in our P sub n. Okay? So our answer ends up being that G, F, and Q are in P3, and H is not in P3. Now we're on to our next section, truth tables. So I just quickly want to recall, sometimes we use letters to signify a statement. So consider two statements P and Q. So we don't really know anything about P and Q except that they're statements. So one thing about statements that you probably remember, hopefully, is that they're either true or they're false. They can't be both, and it's also not possible for them to be neither. Okay? So if I want to write a truth table about them, all I'm doing is I'm listing a statement, so let's say P, and then I want to list out all possibilities for its truth value. Okay, so if I'm just thinking about P, I just have true or false. Okay, that's pretty easy. So, but what if I want to talk about P and Q? Both of them at the same time. So let's see, I have true or false for P, but I also have true or false for Q, and I want to consider all possible combinations of this. Okay, well, when P is true, Q could either be true or false, okay, because we don't know if they're dependent on each other. Okay, so let's say, so Q could be true or false. Now if P is false, same thing. Q could be true or false. Okay, so what we end up with is 4 entries. Okay, so how about if we had 3 statements, P, Q, and R? Whew. So P, Q, and R. So now it's going to be basically the same thing. Okay, so so spoiler alert, I'm going to list true 4 times, false 4 times. Okay, and then Q, true, true, false, false, true, true, false, false. And now R is going to be alternating. And now this is going to ensure that we have all different combinations. Now, if for some reason you wanted to add on a 4th statement, it's basically the same thing. You'll have 8 trues and then 8 falses for P, 4 trues, 4 falses, 4 trues, 4 falses, etc., etc. Okay, it'll be the same kind of gig. But these are all the different combinations, each one of these rows. Okay? All right, so now let's talk about some notation. Okay, so if I write this little downward V, this means the word and. Upward V, but it's not literally the letter V, okay? This means or. So this weird arrow to the right, let me draw it again. Like that. Please do not go talking about that. That means something different. This means it implies. So blank implies blank. Or another way to say it is, if blank, then blank. And what do I mean about these blanks? So the blanks would be what goes in front and what goes after the arrow. Okay? This thing means not or negation. So the word that it means is not, but it's a way to negate something. Okay? And then this guy right here, this last notation means blank if and only if blank. Okay, and so we'll get more into that later. Okay, this is just getting the notation down for right now so you have something to refer back to later. I'll be exploring a lot of these different things. So let's start talking about truth tables that relate to these. Okay, so I got us started with P and Q. Now let's talk about P and Q. So I think the best way for me to show this to you is by talking about examples throughout. So my example for this P and Q is, let's say P is a statement that X is an A, and Q is a statement that X is an B. So what does that mean about P and Q? So P and Q would then mean that X is an A and X is an B, which in turn means that X is in the intersection of both of them. Okay, that's in the intersection of A and B. So when is it true that X is in A intersect B? Well, it has to be that X is in A and X is in B, right? Both at the same time. It can't be that X is just in A, but it's not in B, or vice versa. So who am I looking at? So this first line, we have that it is true that X is in A and X is in B. Okay, so then it's true that X is in the intersection. Well, here X is not in B, so it's false. It can't be an intersection. Similarly here, and of course down here. Okay? So how about P or Q? Let's use the same P and Q as before. Then P or Q means that X is in A or X is in B. And remember, this means and or. So both could be true. That's okay for us. So what does that mean? That means that P or Q is the same as saying X is in A union B. Okay? So we just need X to be in one of them. So it's true up here because it's in both. It's true because X is in A. True because X is in B. Okay, but this is false because both P and Q are false. Okay? So this probably lines up with a lot of just how you talk, right? So if P and Q both need to be true, for the statement P and Q, right? And then similarly, P or Q need to be true, maybe both of them are true, for P or Q to be true, right? So it kind of lines up with how we talk about things. So this is the one that's always hard to come up with examples. So let's say that P is the statement, you give me $25. And Q is the statement that I will order takeout, or I order takeout. So if P then Q is how I would read this statement right here, okay, means if you give me $25, then I will buy takeout, okay? So let's talk about when it's true, that statement is true, and when that's false. Okay, so kind of how you could think about it is if I said that as a statement to you, under what circumstances would that be a lie, and under which circumstances would it be not a lie? Okay, so let's say this first circumstance is it's true. You do give me $25 and I do order takeout. Okay, so then that means that it was true what I said. Okay, how about this second scenario? How about this second scenario where it is true that you do give me $25 and then I don't order takeout? Well, that makes me a liar, because you went through with the if part was true, but the then part, no. So then it was false. I was a liar, okay? So let's say you don't give me $25. Well, now it doesn't really matter if I do order takeout or not, right? Because now no matter what, it was not a lie that I told you. We can't prove that it was a lie. So if the if part is false, then it doesn't matter what the then part was, because you didn't start the chain reaction. You didn't see what happened. A statement like that where the if part is false is called vacuously true, because it doesn't matter what the then part is, because the if part is false, then it's vacuously true. How about the other direction? How about Q implies P? Another way that we could write this is, if you wanted to keep P and Q on the same sides, is you could just point the arrow in the other direction. And just like subset, when you flip it around, this still reads Q implies P, even the top one, okay? So what happens with that? Well, it's still kind of the same thing. If I order takeout, then you'll give me $25, okay? So if I say that statement is true if I do buy takeout and you do give me $25, okay? That's this first scenario, so that's true. In the second scenario, I don't buy takeout, but you still give me $25. Okay, well, just like I said before, that's vacuously true. Okay, maybe the $25 has nothing to do with the takeout. Maybe I didn't even order takeout for you. I don't know. So the third scenario, I order takeout and you don't give me $25. Okay, so that's going against what we said was going to happen. Okay, that makes this statement false, right? So if the statement is, I order takeout, you give me $25. Okay, so the first part is true. I did order takeout, but then you didn't give me $25. So that statement was false. Okay. So let's say I don't order takeout and then you don't give me $25. So the statement's still true. And it's vacuously true, like I said before. Okay? So what you may be thinking is, well, what if I know I have a flaky friend and I want to make sure I get my $25 for this? Maybe what I would say to them is, I will order takeout if and only if you give me $25. Okay? So that's going to look like, let's keep the P on the left-hand side. P, and then we have like the double arrowhead. And that'll make sense later. We'll talk about this in the next video. So this reads P if and only if Q. Okay? So it's only true when they agree with each other. Okay? So in this first scenario, you give me $25. Oh wait, yeah, you give me $25 and I order takeout. Okay, so if you gave me $25, only if I order takeout. Boom, that was true. So this next one, you give me $25, but I don't order takeout. So that makes this statement false. Okay. You don't give me $25, but I still end up not ordering takeout. I'm sure we've all been in that scenario. So that ends up being false because the statement is false because I didn't order takeout if and only if you gave me $25. Okay? And then you didn't give me $25, so then I didn't order takeout. Or whatever order that happened in. It just so happened that you didn't give me $25 and I didn't order takeout. Okay? Well, that's still true. You didn't give me $25, so I wasn't going to order takeout, or maybe it went that I didn't order takeout, so then you weren't going to give me $25, or maybe they happen synonymously, if it's some different P and Q. So then our statement was true, that it was only going to happen if and only if the other thing was going to happen. Okay, so how you could think about if and only if is they're it's only true, an if and only statement is only true when their truth values agree on either side of that if and only if symbol. So it's only true when P has the same truth value as Q and when Q has the same truth value as P. Okay? We'll talk about that more later. So if this is a little bit confusing right now, that's okay. I just like to introduce it all to you. It may be a little overwhelming right now, but then it'll soak in your head. And the next video, we'll talk about it some more. In a later video. I'm not sure if it's the next video, but